and a very welcome good evening to everyone. I hope you've had an enjoyable week. This week, it's a little bit of a passion for myself, but it's the anniversary of a very old film called Tron. It came out in 1982, and it's a pretty terrible film. I don't recommend watching it. It's very old. The acting is a little bit off. The story's off. But the visuals are amazing. And the reason why is it was the first movie ever made to feature a ridiculous amount of CGI. This is very early CGI. And in fact, I can show you one example of this CGI. Is in one of the scenes, they had a go on what is known as light cycles, where they had to basically outmaneuver their opponent. And as you can see, this is very early CGI. The colours, there's not many shadows, and it's really impressive what they were able to do, even back in the 80s. And the reason I bring this up today is we are going to attempt to recreate a game that was actually available in arcades in the 80s that was based off the movie Tron. And it's something a bit like this. This is Light Cycles the Arcade. It was released by Bally Midway in 1982. And you would go along and you would put 10 pence coin into this arcade machine and you'd be able to play. And the rules are simple. You have bikes. It's either one person versus the computer or two players versus each other. And the bikes can turn 90 degrees and they're always going forward. You can't touch the wall and you can't touch another person's stream that they leave behind. It's basically like two-player Snake, except you constantly make a stream, you don't make your tail longer. We're going to make something that's similar to this, and we're going to make it so it's got a similar aesthetic to Tron, the movie. Now for that, we're going to use arcade.makecode.com. I always come back to this one, it's my favourite. Let me just type it out in chat. And the reason we're going to use arcade.makecode.com is it's going to allow us to change pixels directly underneath the player. And it's not the best engine to use, but it's going to be good for us, just for today. As you probably know, because I always come back to arcade.makecode.com, we've got a simulator on the left, which simulates our game. And you can either use blocks or JavaScript. You're welcome along to follow in either, but I'll be teaching in blocks today. So the very first thing we want to do is we want to set a nice background for our map. Now, Tron, the game, and the movie takes place on what is known as the grid. And if you look up anything that's inspired by the 80s, or any images to do with the 80s, you'll know that everything looks like it's got a neon grid. And that's because of Tron. It had a massive influence. So we're going to make a grid of our own. I'm going to use this on start block. And I'm going to go to scene. And we want to set the tile map. So in the tile submenu, you can find this block called set tile map 2. And basically that gives us a playing field on which we can, move our characters about. And to edit that tile map, I'm going to click in the grey box and it takes me to the tile map editor. Now we could either use the built-in tiles, like flowers, a bush or two, but that's not very computery. The whole idea of the movie Tron is it all takes place inside a computer. So we're going to go ahead and make our own tiles instead. We're going to click on My Tiles, which is next to Gallery. And this little menu allows you to make tiles yourself. And the first tile we already see that's been made for us is a blank, empty tile. We're not going to use that one much. We're just going to click on this plus here to create a new tile. And this gives us a 16 by 16 image on which we can create a tile. Now, I want a grid effect, so how do you make a grid? Well, we could draw out lines. Let's do it in a nice blue. We could draw out lines like that. But that might be too small of a grid. Or it might be, it doesn't look right. So I'm going to show you a slightly cheaty technique of making a nice grid. I'm going to set the entire background to black. I'm going to get blue. And I'm just going to put it down one side and along another to make an L shape. Well, backwards L in this case. Because if you think about it, if we've got lots of these tiles together, they will all look like this. So we've got the same thing side by side. It's going to make a grid, even though we're not making a square. And once I've got that, I could place them all out, but let's first of all make this tile map a little bit bigger for us. Otherwise, we're going to have a tiny space to play our game. We want it, let's say, if I move my mouse down to the bottom left to change these numbers, let's have it 50 tiles by 50 tiles. Yeah, that's about as big as we can go without crashing. And this is going to be where we start. I can select my tile here, the grid I've just made, and I can select the fill tool. And with the fill tool selected, I can just fill in the whole thing. And we get a pretty convincing looking grid. I mean, that already looks like an 80s game to me. The only reason you might be seeing some lines blank or some lines wider or thicker, that's known as the interference pattern. That's what happens when you try and display a grid on a screen made of pixels, and the pixels are arranged in the grid. Anyway, it looks like that, but don't worry, it won't be like that. We're also going to need something to keep the players inside the grid, so we're going to need a wall. Now, I'm going to click New to create a new wall tile. This wall tile is going to basically show that you can't go this way. I mean, we're not going to have invisible walls, we're going to have visible walls. Let's make it purple. Let's do a sort of X pattern. We want to make it look kind of computery. Yeah, I'm not going to spend too long on this. You can't go here. That'll do. Kind of a box. I could fill in the background with black, but yeah, I'll do that. And then maybe just a little bit of highlighting, just to make it sort of stand out a bit. Okay, so now we've got that, and oh, my entire tile map has disappeared. Now, whereas I think if we click done and load it, yeah, there we are. Sometimes arcade.makecode.com will accidentally lose your tile map. If you click done and then edit the tile map again, it comes straight back. We want to draw this around, so I'm going to use the box tool. And being very careful with my aiming, I'm going to draw a nice big border around the edge. Now that's not enough to stop it completely. I'm going to have to do a little bit more work. I need to set the wall. So Arcade doesn't know whether a tile is a floor tile or a wall tile. We need to tell it what's what. And we can do that by clicking this kind of 3D wall icon and using the same tools up here, in this case a rectangle tool, we can draw this sort of red don't go wall around the edge. And that stops the player from being able to drive off the side. If you can turn that on or off with this toggle up here. We need to make sure we have a wall because that's going to be essential for this task. And there we are, we've got the tile map. And if we load up the simulator, which I always forget takes ages. I wish I had mentioned it now. Come on. There we are. We can see that it's loaded in all right. I'm not going to do much on the simulator today until we've kind of finished the game. So on your screens, keep testing it, keep seeing what works, what doesn't. I'm not going to use this much because, as you can see, it takes ages to load for me. But yeah, we've got our grid. Okay, what do we need now? Well, we need some players. We'll need 2 sprites, one for the player, one for the enemy. So I'm going to go to sprites. I'm going to, where it says set my sprite to sprite of kind player, I'm going to use that one. I don't want to call it my sprite. My sprite's a very boring, awful variable name. My sprite, I don't know what it means. I'm going to rename this variable by clicking on the down arrow, and I'm going to call this the player sprite. And this is where I get to design it. If I click in this grey blob here, I can draw it out a bit. Now, I've already made this game and I've experimented with it, and there is a slight error in the code if you make a sprite where it goes up to the edge. So my advice is keep it 16 by 16 and keep it kind of around about the middle almost. Let's do it orange. Let's make an orange player. Is that middle? No, it's not. That's middle. Let's have a kind of cross. Oh, someone's asked on Discord if I could go back to the tile map for a second. Yeah. So back to the tile map. If you ever need to edit your tile map, you can always click on the bit here. I've got 2 tiles. One is the grid, which looks like that. It's just a black background with a coloured line on 2 of the sides. And I've got a wall, which is, well, the wall can be anything of your design. Maybe I don't like the shaded part. I can get rid of that. Oh, and apparently get rid of that bit as well. And the most important part is it has a wall around the outside. Where's the pan tool? There's the pan tool. If I zoom in and drag over here, we can see that I've put my wall tile around. I've just placed my wall tile, so one there. I could put more walls in the center if I wanted to, but I've just put down some wall tiles. And to tell Arcade that a wall tile is a wall tile, I've gone on to the 3D sort of wall shape, and I've drawn a wall there. So I'll demonstrate that out. At the moment, the player can pass through these purple bricks, but if I put the wall icon, if I click and put these back, then the player can't pass through them. Anyway, I hope that helps. Yeah, and just edit your tile map by clicking here. We will need to come back to the tile map at some point, so good to know where that is. Let me finish off the sprite. Let's just kind of make a, I don't know, have a little bit of yellow highlight. I'm making a kind of a sort of omnidirectional kind of a bike almost. You know, imagine if you had a bicycle that could go 4 directions at once. And, oh, missed a bit of highlight there. Yeah, just more orange everywhere. Oh, even where I don't want it. You could, of course, use the gallery up here to load something in, but I find there's not much by way of sci-fi in the gallery. It's very princes and princesses, bushes, that kind of thing. I want something a bit more abstract, a bit more sci-fi. Let's have a yellow highlight there as well. Okay, I've got that. I want to make an enemy player too. So rather than draw out the whole thing again, I'm just going to right click on this block here and duplicate. And rather than setting the player sprite, I'm going to click on that drop down arrow and make a new variable, which is going to be my enemy sprite. So I've got 2 sprites. This top one is orange and it's of the kind player. I've got an enemy. It's also orange, which I need to change, and it's also a player, which I need to change. So let's change that to be an enemy first. So sprite of kind, and if I click that drop down arrow, I can change that to enemy. Sprite of kind enemy, and if I click on here, I can edit it about a bit. And let's make it red. Let's use the fill tool. Let's just make it red. You don't have to do the same design as I have. It's completely not necessary. In fact, you can do whatever you want to. But there we are. We've now got 2 enemies. If I load up the simulator, which will take about 5 years, you'll notice that as soon as we are creating sprites, that they land on top of each other when they spawn in. As you can see, it looks like there's only the red sprite here, but in fact, it's got the the orange sprite underneath it. We need to change that. We need to fix that, because if we've got, later on, we're going to write a rule which says if the 2 sprites collide, someone loses a life. We need to fix that, really. So I'm going to go and set the positions of either of these sprites to make them out of the way. So if we go into sprites, we can set position of a sprite, which is the second block down. Now, my sprite doesn't exist, and it's warning me that it doesn't exist. So I'm going to change that to player sprite. And here is where we set its position. Now, I'm going to be doing some complicated maths in a little bit, because I want everything to stay on a grid. The reason for that is if we keep things stuck on a grid, it works much better. It's got better collisions, it's got better light streams that the bikes create. We're going to keep everything on a grid. And if we look back at our tile map, we'll see that all the tiles are 16 pixels across and 16 pixels down. And we need to keep the number 16 in our heads, because that's exactly what we're going to be using most of. Now, I'm not sure whether you can make this out, but if I set my player to 0, 0, we can see that the player is in the top left-hand corner, which is kind of useless because currently is outside the wall. If I were to set their XY coordinate to 16 by 16, we can see that they're now in the top left-hand corner, but they're kind of in the middle of 4 blocks. I need to work out what numbers do I need to get that sprite to sit exactly in the middle of this square here. And it's quite easy. The position of a sprite is relative to the center of the sprite. So the center of the sprite, if I tell a sprite to go to 0, 0, it's going to grab its center and move its center exactly over 0, 0, or 16, 16. And if a sprite is 16 pixels wide and 16 pixels tall, and we want its center to be in the middle of a block, that means I must add half the width and half the height onto that number. Let me demonstrate. Let me go back to where I set the position. So currently its position is 16, 16. If I add half the width of the sprite, which is 8, because the sprite is 16 by 16 pixels in resolution. If I add 8, which is 16 divided by 2, to 16, I get 24. And the same for the Y, 24. And if I look back at the simulator, I can see it's dead set in the middle of the tile. So I've taken the width, I've added 8 to it to get 24. I've taken the height, I've added 8 to it to get 24. 24, 24 is the position that it should be. And every single middle of each tile is going to be 16 plus however many it's going to be maths isn't my strong point. Anyway, it's going to be 24 plus 16 for that one, plus 16 for that one, plus 16 for that one, plus 16 for that one. So it's going to be 24 plus however many lots of 16 there are going to be. So I've already worked out the maths beforehand. If I want to move my enemy down to this bottom right-hand corner, I need a position that is a multiple of 16 plus 8. So let's go to sprites. Let's go to set position. And I don't want player sprite anymore. I want to change my enemy sprite. And I'm going to use the value 152 and 104. And if I open the simulator, we can see it's sat nicely in the middle of a square. Now, don't worry about the maths. If you don't want to do the maths, that's fine. Just use the numbers I do, and everything should be fine. But we can see that our enemy is nicely positioned. Okay, what now? We've got 2 sprites. Let's get about to controlling them. Well, controlling the player. I'm going to go to controller. And I could use this block here, move my sprite with buttons. But the problem with that is it doesn't make sure our player is stuck to the grid. It means our player can move between lines. We're not going to do that. We want our player to be only able to move along a grid. So instead, we're going to use on button pressed, which is the second one down. And we want 4 of these. We want one for when the up button is pressed. And we want one for the down button, left button, and right button. So I'm going to write out the code for the up button first, and then I'm just going to duplicate it until we've got 4 of them. Right, let's store the value of the direction that the player should head in a variable. I'm going to go to variables, click make a variable, and I can call this player direction. And when the up button is pressed, we can set the player direction to something. I can set it to a number, but let's make it a little bit easier for us to program. Let's set it to up. Now, unfortunately, I can't just write up in here. I'm trying to, I can't. But if you go down to advanced and find text, we can see that it gives us the option to enter text in something, and that's this top part of text. I can grab that, I can stick it in there, and the text that I want to set player direction to is up. And as I said, I need this 4 times, so I'm going to duplicate. And this is going to be down. And the down buttons press set player direction to down. And we need 1 for left. And we need 1 for right. Okay, we've got the 4 things we need. Now, let's get things moving about. And this is where the fun little bit of maths I mentioned comes in. I say fun, it's horrid, but yeah, I'm not a fan of maths. So what are we going to do? I'm going to get my sprite to think to itself, am I inside a grid? Am I in a grid position? If I am in a grid position, then I'm going to check whether or not the player has pressed a button, and if they have, move, and if they haven't, don't. And that's all it is. It's just when it comes to checking whether or not the player is inside the grid is a little bit maths heavy. But I'm going to take it slow and take it step by step. And as always, I will publish the code on the TechnoCamp's website afterwards. If we go to game, there is this function called onGameUpdate. And this happens 60 times every second. It happens on each frame of the game. And it happens, 60 times a second. That's quite a bit. So at that rate, we're going to be checking whether or not the player is on a grid. And if we're checking something, well, we're going to need an if statement. So the first thing to get is logic, if. And this is where the fun begins. So what do I need? I need to grab the player's X position. X is side to side. So if I go to sprites, we can find this option for my sprite X. And that's a rounded one, so that means it's a value. I'm just going to plonk it there. It turns yellow because we're not doing anything with it. And we're not going to be looking for my sprite, which doesn't exist. We're going to be looking for player sprite. We want the X position of the player sprite. And to get the center of that, we need to -8, because the player is 16 pixels wide. We need to find the center of it, so 16 minus, well, its position -8 will give us the top left-hand corner. So if you go into math, we can find this minus block here. And I'm going to grab my player sprite's X position, put it in the left-hand side, and I'm going to change that number to be 8, so it's -8. I appreciate this might be hard to see what of it being quite yellow coloured. So player sprite x minus 8. Now this is where the maths gets funky. I'm going to do what is known as modular division or integer division. And basically it's saying how many times can 16 fit in this number? Is this number a multiple of 16? Now, if it is a multiple of 16, when we do this number modular divide 16, it will produce 0. It's basically saying, what is the remainder? If we go into math, we've got this remainder of block. It's a remainder of 0 divided by 1, or whatever number divided by whatever number. And this is the important bit. It's the remainder of block. And this is going to do all the heavy lifting for us. So I'm going to grab this whole thing where I minus 8 from the x position. I'm going to put it in the left. Let me zoom out. And I'm going to be dividing it by 16. And that's the hard part of the maths done. That's it for the hard part. Now we need to check whether this whole thing is equal to 0. So we're going to use a comparison, which is in logic. And comparison is something equal to something. I'm going to put that in there. And I don't need to change any numbers in that, because is this whole thing equal to 0 is what we're looking for. Okay, not quite done. We've done the x part of things. Now we need to do the y part of things. The up, down. So rather than write this out all again, I'm going to right click and duplicate. And rather than looking at x, I'm going to click this drop down arrow and change it to looking at y. Final part, and I hope you'll agree with me that this produces the most ugly bit of block-based code ever, but we need to say, are both of these things true? And if both of these things are true, then continue. And so we're going to need an and. We're going to say, is this first part and this second part true? You can find and in logic. So logic. And under the Boolean tab, we're looking at something and something. And we're going to put this one in the left. And this is where things get unmanageable. We're going to put this one in the right. And as you can see, that's an awfully long piece of code, and it's so long that it's a bit hard to zoom in and see it all on one screen. But yeah, we need an and that combines those two bits together. Okay, final step. I'm going to grab this whole thing, this big, massive, long, ugly sentence of code, and I'm going to put it inside our if, the if inside the on-game update. And there we have it. A really long if statement. And all that's done is it's asked Arcade, is our player on the grid? Are they right in the middle of a tile? Now, other game engines out there, like Game Maker or Unity or Unreal Engine, they've got a lovely, wonderful little option called Snap to Grid that does all this for you, but not Arcade. So we've had to do that ourselves. And that's quite a nice complex bit of code, so you should feel pleased to have done that. If the player is on the grid, this is where we make our decision. We say, this is where we move the character. And basically we're going to ask, is it one of these? And if it is one of these, do that action. So if the player direction is up, move up. So I'm going to need an if statement. Plonk it in there. And we're going to be doing this 4 times for each of the variables. So I need 4 else ifs. And I can find that by clicking this plus icon at the bottom of the if, and it makes an else, which I don't want. But if I press plus again, it gives me an else if. And I want to keep pressing plus until I've got 3 else ifs and an else. If, else if, else if, else if, else. We don't want the else. So we're going to click minus next to the else. And you should have an if statement that looks a bit like that. And we're going to check whether or not the player direction is set to a certain value. If I go to variables, we can get the player direction. How do I check whether it's equal to something? Well, I need a comparison, so I'm going to go to logic and find equals. What's next? Oh yeah, and I need to compare player direction with some value. So let's stick player direction inside the equals. And if we remember that we wrote the up, down, left, right using text, so I need to go to text again, and I need to grab the speech marks, and I'm going to say if player direction is equal to up, and I can put that inside the if. So if the player direction equals up, then move the character up. Else if the player direction, let me rephrase it in a better way. Else, if the player direction is equal to down, move down. Else, if the player direction is equal to left, move left. Else, if the player direction is equal to right, move right. So I need to duplicate this 3 more times and change that to down. And duplicate and change that to left. And duplicate that and change it to right. And now this is where we actually move the character. For that we're going to need to use velocity, which changes the speed of a character in a given direction. So if you go to sprites, the third one down is set velocity to some value. And I'm going to grab that and I'm going to plonk it in there. And this is going to be not my sprite, but player sprite. And well, if X is side to side and Y is up and down, well, 50-50 is going to move them diagonally because it's moving both in the X direction and in the Y direction. So we don't want that. So I'm going to set those to 0. But 0, 0 means it's not moving in any direction. It has no velocity in any direction. I want them to go up. And if we remember, up is Y, and as you go up the screen, Y gets smaller, and as you go down the screen, Y gets larger. Then if we want to go up the screen, we need a small value like -100. Now -100 is quite fast, but it moves up the screen. Let's do down. Let's copy this exact piece of code by duplicating, and we're going to put it in the down option. And rather than going -100 in the Y, which is up, we need to go plus 100 in the down. So to change that to plus 100, I just delete the minus sign. So minus 100 y for up, plus 100 y for down. And as you can imagine, left and right are changing x rather than y. So let's duplicate this. If we're moving left, we don't want to move anything in the y direction, so I'm going to change the y to 0. And I'm going to change this, well, what should left be? Well, if the top left of the screen is 0, 0, that means x gets smaller on the left and bigger on the right. So that should be minus 100 to go left. And as you can imagine, it is plus 100 to go right. Just 100 on its own. Okay. I think that is everything to get our player moving. We can give it a test. Or in my case, we can click the arrow and wait ages for the simulator to load. Oh, this has actually taken longer than I thought. It's quite embarrassing, actually. How was your day? Anyone see that ludicrous display last? Ah, no, there we are. Okay. When I click down, it moves down. When I click up, it moves up. When I click right, it does nothing, and I know why. It's because I've crashed into the wall. We can actually demonstrate right if we reload the game. Down, left, up, right. And notice that no matter how I move it, it's always staying inside this grid until I crash into a wall. But we'll deal with wall crashes in a bit. Now, you notice that my character was able to go off screen. That's not really useful for us. We need to be able to see our character. So if I go to Scene and scroll down to the very bottom of Scene, notice that we can set the option to Camera Follow Sprite. And this makes the camera follow the sprite no matter where they go around the room. Now I'm going to grab that and I'm going to put it inside my on start because this only needs to run once. I also need to set it to player sprite. So the camera will follow the player sprite. Okay. Let's now fix the next issue. What happens when they hit the wall? It just kind of freezes there in place. Let's make that a little bit more interesting. Let's actually make that a mechanic of the game. If you hit the wall, you die. So to do that, I'm going to go to Scene. And I'm going to scroll down. And we got this option of on sprite of kind player hits wall. And basically that's saying when the sprite hits the wall, do something. Okay, what are we going to do? Well, I've planned this a little bit in forethought. I know that we're going to be killing the player a lot, so it's easier and faster if we just write a quick little function that deals with player death for us, and it does all that. You know, we don't have to bother. So if we go to functions, we can make a function. And we can call it name. This is going to be player death. And MakeCode likes to put functions at the top where I don't like them. So I'm going to move that back down to where I'm working. And in here, we're going to deal with everything that kills the player. Now, the first thing we should do is we should clear the entire game. And the reason we're going to do that is because if they hit a wall, but their velocity is still set, then they're going to carry on hitting the wall as they die, which means the dying code is going to call again and again, and trust me, I've heard the same sound effect constantly, and it's a mess. So we need to reset the entire map. So I'm going to grab this set tilemap 2, and rather than have to draw this out all again, I'm just going to duplicate the one that we've already written. And basically it will refresh the tile map for us. And the reason why we're doing that is because we're going to be drawing on the tile map. And we want a nice fresh tile map to work with after the player dies. So I've just duplicated that from the one in onStart. And I move the copy into player def. Next thing we should do, we should probably get rid of the player's sprite, because we don't want that still being there messing things up. So if we go to sprites and we have destroy my sprite, rather than my sprite, we don't want to destroy that. That doesn't exist. We can't destroy something that doesn't exist. We're going to destroy player sprite. And if we want to make it fancy, we can click this plus option and we can set what effect the destroy has. And if you click this down arrow, you can see there's lots of effects. You can have confetti, heart smiles. Now, in Tron, the movie, when a player dies, they get what is known as de-resed. And basically you get taken apart pixel by pixel. It's a really cool effect for 1982. And the closest thing I found to that was fire. Fire destroys your sprite pixel by pixel. It's a really cool effect. And, well, let's spice it up a little. Let's get it to play a sound effect. Now I'm going to be a little bit cheeky and do something that doesn't make sense. I found that if you used player def and you put a sound effect to happen after the player was destroyed, the sound effect would play again and again and again. It's a small bug in Arcade. So to get around that, we're going to use another function. We're going to go to sprites. And if you scroll down to life cycle, we can have on destroyed sprite of kind player. Now, effectively this function is called when the player is destroyed. So this one destroys the player, and that will fix it. Oh, someone's got a problem with their tile map. It looks to me, Jack, that you have set the wall to be the entire tile map. So what you need to do is you need to how do you delete a tile wall? You need to click on this icon to go into wall editing mode. Then you need to click this erase tool, and you can erase the wall bit by bit, but if you click this square in the top left, it gives you a larger erase. So it's easier to erase the wall. See, I'm erasing the wall here. You need to make sure the wall is only on the outskirts. It's not in the middle. I hope that fixes your problem. If not, give me a shout after the stream is over and I will take a look at it for you. Anyway. So when the sprite is destroyed, we want to play a nice little ditty. So let's go to music, and we can play sound. Let's compose our own. Let's play melody. I want it to be quite fast, so I'm going to set this to 300. And let's do, I don't know, no. that's horrid, but yeah, I don't care. You can put it to whatever you want, but nice little ditty just to say, oh dear, you've died. Let's get this to actually call the function so it actually happens. So if we go into functions, call player def, then this function will take place. Okay. We need we don't need that one. Let's move straight on to the next bit. Now, the whole point of the light cycles game is that when a character drives along, they leave behind a trail. And if the enemy runs into that trail, the enemy dies, and if you run into the enemy's trail, you die. So what we're going to do is we're going to say, if I am touching a blank space, I'm going to change that space to be, my trail. And for that, we're going to need some new tiles. So if you go to your onStart function and your tile map, and you edit your tile map, we need to add 2 new tiles. We need 1 tile for the enemy's trail and 1 tile for your trail. So I'm going to click plus down here in my tiles to create a new tile. I'm going to choose a colour that stands out against the background and makes my sprite stand out. Let's go blue. In the game, it's orange versus blue in the movie. Let's go this kind of turquoisey colour. And I'm just going to fill out the entire tile with that colour. And it's just going to be a single tile of 1 colour. If you wanted to be fancy, you could add some, splashes or swishy effects. But yeah, no, why not? I'm going to leave that in. No, I don't know. It's closer to the original if I don't. It's up to you. Be creative. So I've got a tile for me. I need a tile for the enemy, so I'm going to click plus. Let's give them a orange tile, yeah, and just fill the whole thing orange. So now we have 4 tiles. We've got the grid, we've got the wall, we've got the player's tile and the enemy's tile. I'm going to click done. And what we're going to do is we're going to say, if I'm touching a blank tile, place down my tile. And we're going to do that 1 for the player and 1 for the enemy. And we can do that by going to Scene. And we can scroll down. And around about the middle in tiles. Let me show that again. There is this function on sprite of kind player overlaps a tile at location. It's a bit of a mouthful, but we're going to use this one. It's quite a long C-shaped function. I'm going to plonk it over there. I'm going to say on sprite of kind player, because this is the player, overlaps, we're going to choose the base tile that we've used, the tile that forms up the background. And it is this one. We're going to say on sprite of kind player overlaps at location. What do we need to do? We need to change that to a player's tile. We can do that by going to Scene. And if we scroll down, underneath the one we just used, there is this set. Let me show again. There is this set tile at Tilemap column 0, row 0. We're going to use this. And all it does is it places down a tile where we tell it to. And we're going to place down the player's colour, which I had this kind of turquoisey colour. And, well, which location do we set at? Because we don't know what column it is in or what row it is in. And this is where this location variable comes in. This function creates a new variable called location. And that location is the location where the player overlaps this tile. It's the location of where this function is first fired. So I'm going to grab that, and I'm going to replace Tilemap column row with it. And you just find location just in this function. So it should look exactly like that. And we're going to need one that is the same for the enemy. So I'm going to click that, and I'm going to right click and duplicate. And I'm going to make sure that I change it from player to enemy. And I'm going to change it from the player's color to the enemy's color. And that should be as good to go. For now, we need to add a little bit. Let's just have a look at what happens. Okay, when I set my player about moving, we can see that they leave a trail behind them. And that's exactly as it should be. And when they hit the wall, they dissolve and die. And yeah, that's the first part. I realise that I am very much coming towards the end of the session. I do apologise, I've run over. Usually we end these sessions at 5:30, but there's a little bit more for us to do here. I want to add some enemy AI. So if you want to leave, that is perfectly fine. You can always catch up on previous live streams from the TechnoClub's website or from where you're watching it now. If you want to stick around, that's great. I'm going to carry on as is. So apologies for running over, but let's just keep forging ahead. Right, so we've got the trails being made. We need the enemy now to actually do something, because at the moment the enemy just sits there. So what I'm going to do is I'm going to find myself some free space. Let's say over here. And I'm going to have a function that is there for the enemy's AI. And what the enemy is going to do is it's going to choose a direction to go, and it's going to go there. So let's go to functions, and let's make a function. And this function I'm going to call enemy AI. Now, I shouldn't call it that because this isn't really artificial intelligence. This is a very dumb, enemy. It just does things randomly. It doesn't put any thought into it. You're welcome to extend your enemy's AI so that they're a little bit smarter. But I'm just going to do a very dumb enemy at the moment. And basically what I'm going to do is I'm going to choose a random direction and I'm going to go that random direction. And to store that, I need a variable. So variables, make a variable, and I'm going to be really imaginative and really flex my imagination and call it enemy direction. Very predictable. So we've got a variable called enemy direction, and I'm going to set enemy direction, and I'm not going to set it to 0. I'm going to set it to a random number between 0 and 3. And I'll explain why I do that. And to do that, I go to math, and there is this block here called pick random 0 to 10. And I'm going to pick a random, but it's not going to be to 10, it's going to be to 3. So we can choose 0, 1, 2, or 3 inclusive. And basically what I'm going to do is I'm going to say, depending on what number it chooses, I'm going to move in that direction. Oh, sorry, a direction. So let's, in our heads or on paper now, sort of say that 0 is up, 1 is down, 2 is left, and 3 is right. Because that's essentially what we're doing. We're just choosing directions randomly. So let's go to logic. And let's get an if statement. We can say if the enemy's direction is 1, move them up. If the enemy's direction is 2, and so on. And for that, we're going to need an equals. And we're going to need the enemy direction. And we're going to plonk it in there. So if enemy direction equals 0, then we need to set the velocity of the enemy to a certain direction. Let's go to sprites, set velocity. We're going to set the enemy sprite this time because we're moving the enemy. And if we want them to go up, well, that's going to be 0, and y is going to be minus 100 for up. Let's fill out the rest. Now, just as we did with the player, we're going to need 3 else ifs. So at the bottom of the if statement, I'm going to click plus, 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 and then to get rid of this else, minus. And it should look a bit like that. Let me show you again, just to make sure it's second nature. Plus, 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 and then this last minus. And in each of these, we're going to put a different number for this block here. So right-click, duplicate. Enemy direction equals 0. We're going to change that to enemy direction equals 1. Going to duplicate again. If the enemy direction equals 2, going to duplicate again. Finally, if the enemy direction equals 3. Now, we could have done this it's very similar to what we did over here for the players, up, down, left, and right, except we use text there, just to make it easier on the programmer. Here, we're stuck using numbers, because there's not a function that will pick a random text. Okay, so just like that one above, we need 3 more of these. If they're moving down, that's going to be 100 rather than minus 100. We need 1 for left, which is going to be 0 in the y, but minus 100 in the x. And if we grab that, if we want to move them right, it's going to be 100. So this function, when it's called, will make the enemy choose a random direction and move in it. So how do we call this function randomly as well? Because we don't want them to make that decision every second or every 3 seconds. We want them to change their decision randomly. Maybe after half a second they decide to go left, then half a second more they decide to go right, then after 10 seconds they decide to go down. We're going to do that. And to do that, we're going to use another block from game. And where it says on game update every 500 milliseconds, we're going to grab that. This is exactly like on game update, except it happens every, guess what, 500 milliseconds. We don't want that to happen every 500 milliseconds. We want it to happen a random number of milliseconds. How do we get a random number? Well, we grab it from math. We want to pick random. And 0 to 10 milliseconds, that's really quick. It would be a very fast, the AI would be making very fast decisions. Maybe we want them to make slower decisions. We're going to change that from, let's say, 200 milliseconds to, let's say they can travel for 3 seconds, which is 3,000 milliseconds. You can change those numbers to your heart's content. You can make the AI more difficult or more stupid just by changing these numbers to have a smaller gap or a larger gap, or be at the top or the bottom. It's up to you. Basically, every time a random number of milliseconds pass, we're going to call the function enemy AI. And to do that, let's go to functions. We've got call enemy AI. Okay. Is this worth waiting for the simulator to load? Yeah, might as well. Oh, and it loaded instantly. That's weird. And we can already see off the bat that the enemy is making some random decisions of its own. We can actually see what it's decided to do. It goes down a bit. Oh yeah, I haven't programmed the collision detection yet, so it's fine to go through the enemy's beam. That's our next bit. And I hit a wall. So, we can see that the enemy is making its own decisions. Let's add a little bit of code that will say, if I hit the enemy's beam, I die, and if they hit the beam, they die. Yeah, let's find some place to put this in our code body. Let's put in this gap in the middle. Basically, what we want to say is, if I am touching a enemy's color, die, and if the enemy touches my color, they die. And the way to do that is we need to check this every single frame of the game. We can do that by going to Game and On Game Update. And basically we're saying, if I'm overlapping, so if, and we go to Scene, we can find there is a diagonal shaped collision option. If tile to left of my sprite is of a certain kind, and we can change these values. So it's the second diamond shaped of the collisions submenu. Actually, I'm going to move this about because it's not got enough room to be in the center there. Let's stick it down there. And it's good to keep your code organized so you know where everything is. Right, so let's change this default about. So I'm not going to check whether the tile to the left of my sprite is that. I'm going to say tile to the center of my sprite. And it's not going to be my sprite, it's going to be player sprite. The tile to the center of player sprite is, and here is where we select the enemy's color. If they hit the enemy color, what should we do? Well, we should kill the player. Luckily, we already wrote a lovely little function that does that for us. We can find that in functions, call player def. Okay. Now we need to do exactly the same for the enemy. So if, I'm going to stick that if underneath. Let's not be lazy. Let's go tile to the, get in there, tile to the center of enemy sprite is, player's colour, then what do? Well, we should probably destroy the enemy's sprite. Let's go to sprites. Oh, that's the wrong one. Let's go to sprites and find destroy. It's in effects. Destroy enemy sprite with fire effect. Yeah. Oh, one last thing we should cover. What happens if the player and the enemy collide? We should probably do something there. Yeah, let's kill the player as well. Let's make it even more miserable for the player. So we need another if. And under sprites, we've got an option to... where is it? It's a diamond shape. Yeah, if my sprite overlaps with other sprite, we can change my sprite to be player sprite and other sprite to be enemy sprite. So if my player overlaps with the enemy, then I should kill the player, and we've already made a function that does it for us. Okay, that should be a pretty polished game. So I can move around. Oh, I accidentally hit my enemy's colour, so I lost. Let's see if that happens again. Yep, I die. One last test. Yeah, there we are. One thing we need to test is what happens. Does the enemy ever die if they collide with our thing? Now, to test that, I actually have to be good at the game, which is a slight problem because I'm not. You'll find there are far too many developers out there that are bad at the game. I was talking then, but you might have just seen that we saw the enemy die on the left-hand side. It was brief, but it was there. So, yeah, that does work. Anyway, I'm going to stop now because I've gone around about 12 minutes longer than I should have. Either today or tomorrow, most likely tomorrow, I will have a runnable version of this up on the TechnoClub's website. You can find that at this link that I am posting in chat. If I remember the right key combination. There we are. Other things to mention. This has been mentioned in yesterday's live stream, but we have just opened up our Summer of STEM. These are several fun lessons taking place over summer, and there are all sorts of. There's lots of variety. I'm teaching a session on animation. If you're interested, you can find that at this link here. And finally, luckily, there is a wonderful website that has actually saved and restored the arcade machine that we have based our game on. And you can actually play the original. And, well, the original is much better. But if you want to play it, you can head over to archive.org and you can actually play the original version here. It runs the game in your browser, and well, it's the original arcade game. So you get to experience what children of your age were actually seeing and playing in arcades back in the 80s. Oh, apologise for the flashing. And yeah. You can actually play the original arcade game. So, anyway, I hope you've enjoyed the session. The version that I'll be uploading to the website. It has a couple of extra features I didn't get around to making. If you wanted an extension task, you can make it so you could have more enemies. Oh, this is the demo mode of the arcade game. This is one of the mini games in it. It's good fun. Go play it. And as you can see, 80s grid pattern. So now you know where a lot of 80s aesthetic comes from. Anyway, I hope you've enjoyed and have a wonderful evening.